Hello viewers, today we want to have a Form 3 physics lesson, and it's teacher Nyangoya from Kizi School. We welcome you to this lesson. Today we shall look at linear motion, and under linear motion, at the end of this topic, you as the learner should be able to define the following terms: distance, displacement, speed, velocity, and acceleration. Then part B, we describe experiments to determine velocity and acceleration. Then C, we determine acceleration due to gravity. Then we can be able to plot graphs on motion, time graphs, apply the equations of uniformly accelerated motion, and solve numerical problems. Today, we'll only handle the first objective, that is define distance, displacement, speed, velocity, and acceleration. So we start with introduction. This topic deals with the study of motion of bodies in a straight line. So the first term we want to define is distance. Distance is the actual length covered by a moving body. It has no specific direction and is therefore a scalar quantity. The SI unit of measuring distance is the meter, given symbol m. Number 2, we have displacement. Displacement. This is the distance covered by a moving body in a specified direction. Displacement is therefore a vector quantity. The SI unit of displacement is the meter. The only difference between displacement and distance is one is in a specified direction, another one is just total length covered. Illustrating distance and displacement, consider the diagram below showing the motion of a body starting from point A and moving towards the direction shown. So a body is moving from point A to B, then to C. So if you want to get the total distance this body covers, it is AB plus BC, but the displacement is A to C, correct? So you can say at point B, distance covered is AB, while the displacement of the body is AB, in direction AB. At point C, the distance covered is AB plus BC. AB plus BC. While the displacement is AC. AC. In the direction AC. When back at the starting point A, the distance covered is AB plus BC plus CA. That is the total distance covered. While displacement is 0 because it will be A to B, A to C, and then finally back to A. The displacement is 0 because this body moved A, B, C, then back to A. The total distance covered is A, B, C, and then C to A. But the total displacement, the body was here and it is still here, the total displacement is 0. But if it stopped at C, the displacement will be AC. Speed. This is the rate of change of distance covered by a moving body. Speed is a scalar quantity. So speed is distance covered over time taken. For a body moving with a non-uniform speed, you just get the average speed, where you get the total distance and the total time taken. Instantaneous speed refers to the rate of change of distance of a moving body at a particular point. The SI unit of speed is meter per second. To get instant, you are referring to a particular point. Velocity. This is the change of displacement per unit time. It can also be defined as the speed in a specified direction. So velocity is therefore a vector quantity. And to get velocity is change in displacement over the time taken. For a body moving with a varying velocity, you just get average velocity. That is total displacement over the total time taken. And the SI unit of velocity is meter per second. A tennis ball hits a vertical wall at a velocity of 20 meters per second and bounces off at the same velocity. Determine the change in velocity. Determine the change in velocity. It hits the wall and then comes back with the same velocity. Yeah? What is the change in velocity? Going is 20, coming back is negative 20, so the change in velocity is 0. Acceleration. This is the change of velocity per unit time. It is a vector quantity. Acceleration, we get it change in velocity divided by the time taken, which is actually the final velocity minus initial velocity over time taken. We usually give final velocity letter V and initial velocity is given letter U. So we use the following symbols. A is equal to V minus U over T, where V is the final velocity and U is the initial velocity and T is the time taken. All this must be velocity in meters per second and time in seconds. Instantaneous acceleration is the acceleration of a particular body at a point. Deceleration or retardation is the negative acceleration in which the body moves with a decreasing velocity with time. The SI unit of acceleration is meter per square second. Look at this example. A body moves with 30 meters due east in 4 seconds, then 40 due north in 8 seconds. Determine total distance covered, the displacement of the body, the average, and then the average velocity of the body. Start. The body moved 30 east, then 40 north. Then what is the total distance covered? It will be 30 plus 40, giving you 70 meters. Displacement will be this point and this point, which is actually 30 square plus 40 square, giving us 50 meters. Average speed will be the total distance covered, this plus this, over the time taken, 12. 70 divided by 12. Average velocity, total displacement over time taken, The total displacement is 50, divided by the time taken is 12. The speed of a body rolling on an inclined plane is 10 meters per second when time is 0. At time t 10 seconds, the speed of the velocity is found to be 25. If the body is moving in the same direction throughout, calculate the acceleration. See, when it is noted earlier initial stage, it is 10. The final stage is 25. So at 0 time is 10. At 10 seconds is 25. So we get acceleration is V minus U over T. V is 25, U is 10, and the time is 10. And we get 1.5 meters per second square. A particle is moving with a velocity of 2.0 times 10 raised power of 5 kilometers per hour, is brought to rest in 2.0 times 10 raised power of negative 2. Calculate the acceleration. So this is the initial velocity, then it is brought to rest, final velocity will be 0, and this is the time taken. So calculate the retardation. We say U2, then convert it to meters per second. Convert this to meters per second, it will be 5.5 times 10 raised power of 4 meters per second. Final velocity is 0. So what do you say? Final minus initial, 0 minus this one, divided by this time. You get the answer as negative 2.7778 times 10 raised power of 6 meters per second square. Therefore, the retardation is negative. So when you say retardation, you say the answer 2 point. But if you say acceleration, it should be negative. Retardation stands for negative value. So you have an exercise for you to look at before our next lesson. That is, a van on a straight road moves with a speed of 180 for 45 seconds and then climbs an escarpment for 72 kilometers per hour for 30 minutes. Calculate the average speed of the van and the average acceleration produced. A girl runs 40 meters due south in 40 seconds and then 20 due north in 10 seconds. Calculate her average speed, average velocity, the change in velocity of the whole journey, the acceleration by the girl. So if you get to do that exercise, our next lesson will be our second objectives on experiments on how to determine velocity and acceleration. With those very few remarks, thank you. Goodbye.